So in last class, we discussed that analysis of frame without space by moment distribution method. Today also I will go through this problem. This is the problem A, B, B, C, C, D. So this problem you have to solve by moment distribution method. So here A, B, B, C, D and B, E and C, F. This is the vertical member. So already we have discussed that in last class. The first step that you have to find out the fixed end moments. This is already discussed. So for span AB, BC and CD and for B and CF. These are the moments. Then the next step is you have to find out the relative stiffness of the members. So this is also we have discussed. So you have to find out relative stiffness of the member AB, BC, CD, B and CF. You know that is if the end is fixed and you have to find out I by L, and if the end is simply supported, so that you have to find out 3I for I by L. So for this span, this member and this member, 3 by 4 I by L, and for these members, this is I by L. Already we have discussed, you know very well. So these are the relative stiffness of the members. Then you have to find out the relative stiffness of the joints. Here you know this is one joint and this is another joint, and here also there is 3 member midst. So you have to find out what is the relative stiffness of the joint. You have to add KBA, KB, KBC is equal to KB. Similarly for KC, KCB, KCF and KCD. So this manner you can find out what is the relative stiffness of the joints. Next step is you have to find out the distribution factor of the members. So here you know that is if the end is your this is fixed, so the distribution factor 0, and this is simply supported, distribution factor you have to take 1, and for all other end of the members you have to find out what is the distribution factor BA, BC, B, CB, CD and CF. You know that is how to find out the distribution factor. So the distribution factor you can find out that is equal to the relative stiffness of the member divided by the relative stiffness of the joints. So for RBA, you have to find out KBA divided by KB, relative stiffness of the member by relative stiffness of the joint. This manner you can find out what is the distribution factor for the members. These are the distribution factor of the members. So here you say what you have to do when you are going for the distributing the moment. Here you have to take 2 tables. So one table is that is you have to take for ABCD. For ABCD you have to go for one table, and for B and CF vertical member you have to go for another table. Take 2 tables, and using these 2 tables you can find out what is the final moment by that is on distributing the unbalanced moment and by carryover and balancing, carryover balancing, that process, that iterative process, you can find out what is the final moment of the total frame. So here you take one ABCD, that is a horizontal member, draw vertical line just below ABCD, and you have to write what is the relative stiffness of the members I by 4, and you have to write what is the distribution factor for RAB 0, RBA 1 by 3, and RBC 1 by 3, and RCB 1 by 3, RCD 1 by 3, and RDC 1. Similarly, for vertical members, you draw another table for column B, and this is for column CF. So here you see this is top and bottom. The top of the column, this side you write, and for bottom of column, write this side. Similarly, for column CF, for top you write this side, and for bottom you write this side. And you know what is the relative stiffness, the vertical member I by 4, and here also this is I by 4. Then you know what is the distribution factor, already you know. At the top, what is the distribution factor, you write this side box, and for bottom, you know 0 distribution factor. Similarly, for column CF, here you write what is the distribution factor this side, and what is the distribution factor this side. Then you got what is the fixed end moment. So you write the fixed end moment for MFAB minus 40, and MFBA plus 40, MFBC minus 50, MFCB plus 50, then MFCD minus 15, and MFDC plus 15. Similarly, here also in column, so you know what is the fixed end moment 0, 0, 0, 0, because there is no load in the vertical members. So the fixed end moment is equal to 0 at top and bottom. So first write this one. Then this end, D end is simply supported. This end is simply supported. Just you go to the this is simply supported, and this is also simply supported. But here there is no loading, so the fixed end moment here is 0. But due to this loading and by assuming temporarily, so here you got the fixed end moment MFCD. But you know what is actually moment here, because this is due to simply supported and the moment here is equal to 0. So you have to make, so you have to start from that joint. So distribution of joint D and carryover, because you know what is the moment here, what is the moment here, what is the final moment here, 0. So first you go distribution of this moment or balance of this moment. So this is your plus 15, and when you will balance this moment, so you have to multiply it with distribution factor and you have to put in opposite side. So this is your balanced plus 15 minus 15. So here you got 0. So this is your moment, and this moment will carry over to the other end. Half of this moment will carry over to the other end, minus 15. So half of this moment is a minus 7.5. Then you draw one line here. Then you take the total sum of the moment. Here minus 40, plus 40, plus 40, minus 50, plus 50, 50. And then minus 15 and minus 7.5, minus 22.5. And here already balanced plus 15 minus this is 0. So this is the moment for distribution. Then what you have to do? You have to go for the distributing the unbalanced moment. Here you see this is your minus 40 into 0. When you distribute the moment, you have to find out what is the net unbalanced moment. Net unbalanced moment, and that moment you will distribute to end of the member, which meet at that joint. So here you see here minus 40 into 0, so 0. And what is the net moment here? What is the net moment here? Plus 40 minus 50. What is the net moment here? Plus 40 and minus 50. So the net moment is minus 10. The net moment, net unbalanced moment is minus 10. And this moment you have to distribute to 3 members, because at a joint B, how many member meets? BA, BC, and another one is your BE. Another member is your B. So you have to distribute this unbalanced moment minus 50, minus 10 to 3 members. So minus 10, so that you have to balance by opposite sign, that is positive sign, and you have to multiply it with this distribution factor. So minus 10 into 1 by 3, so you have to put here opposite sign plus, and minus 10 into 1 by 3, so you have to put here in opposite sign plus. Then for vertical member also 1 by 3, minus 10 into 1 by 3, and you have to put here in opposite sign. So this is the balancing the undistributed or unbalanced moment. Similarly, coming to the joint C. So in joint C, so what is the net unbalanced moment? 50 minus 22.5. So this is your plus 27.5, and this plus 27.5, that moment you have to distribute to member CB, CD, and also another member CF. So this is plus 27.5 into 1 by 3, and you have to put in opposite sign, negative. Plus 27.5 into 1 by 3, and you have to put in opposite sign, minus 9.17. Similarly, for vertical member, a plus 27.5 into 1 by 3, and you have to put in opposite sign, minus 9.16. Always you see at the joint C, 3 member meets. So when you are going for the balance, so you have to see this total moment, balancing moment, should equal to the unbalanced moment. Because here 27.5, and when you will add these 3 balancing moment, minus 9.17, minus 9.17, and here minus 9.16 we are taking. So then these 3 is equal to that 27.5 plus 27.5. Then here this is your already balanced. So this is the balancing of the unbalanced moment. Then again you have to go for the carryover. Again you have to go for the carryover, because here you see if the end is your fixed, so you have to carry over to that end. Half of the moment will carry over to that end, and here also that intermediate span, so half of the moment will carry over to the other end. This is half, and this moment will come to this, and here minus 9.17, and end is your simply supported, and this is already balanced. So this moment will not carry over. This moment will not carry over to this side. This moment will not carry over to this side. So here these are the carryover moment. So again you have to go for the distribution or balancing the moment. Distribution, or you can also write balancing the unbalanced moment. So here you see this is the 1.67 into 0. So here this is your 0. And here you see what is the net moment or joint B. So this side is your minus 4.59 and this side there is your no moment. So what is the net moment here? Minus 4.59. So this moment you have to distribute to the member BA, BC and BE. This is your minus 4.59 into 1 by 3, and you have to put in a plus sign, minus 4.59 into 1 by 3, and you have to put in plus opposite sign. And also for vertical member, this into 1 by 3, and you have to put in opposite sign. 1.53. Here you see this is your carryover distribution factor, because here the end is your fixed. So this is your carryover takes place half of the moment to the bottom end, top to bottom. And here there is your simply supported. So this moment is your not carryover takes place. So this way you have to carry over per column from top to bottom. Then, so this is the distribution of the moment. Here also you see here the moment, net moment is your 1.67. This side there is your no moment. So not net is your 1.67. So 1.67 into 1 by 3, and you have to put in opposite sign. 1.67 into 1 by 3, you have to put in opposite sign. And for vertical member CF, also you have to put in opposite sign. After multiplying with 1 by 3 distribution factor, and you have to put in opposite sign. So the distribution process is your over, or balancing is your over for horizontal and vertical member. Then again you have to go for the carryover. Carry over this half of this moment to this side, and half of this moment to this side, half of this moment to this side, and this moment will not carry over. This is for the horizontal member, and for vertical member, half of the moment will carry over to this side. And as the end F is your simply supported, so there is your no carryover takes place here from top to bottom. So this is the carryover. So here the carryover 0.77 to bottom, and here the carryover is your this is 0.77, and here this is 0.77. This is minus 0.28. And here there is no carryover takes place. At the end, D is your simply supported. So this is the carryover. Then again, you have to go for the distribution of the moment. So here you see 0.77 into 0. So here 0. And here what is the net moment at joint B? Minus 0.28. And this side the moment is your, there is no moment. So net moment is your only minus 0.28. And this moment will distribute to BA, BC and BE. So here this you have to multiply it to 1 by 3, and you have to put in opposite sign. This multiplied with 1 by 3, and you have to put in opposite sign. And also in vertical member also minus 0.28 into 1 by 3, and you have to put in opposite sign. This is. Then coming to the joint C. So here what is this side is your moment 0.77, and this side there is no moment. So what is the net moment here? 0.77. So this moment will distribute to 3 members, CB, CD and CF. This one, CF. Vertical member. So this one is your 0.77 into 1 by 3. So you have to put in opposite sign minus 0.26, 0.77 into 1 by 3 minus 0.26. And also you have to put in vertical member 0.77 into 1 by 3 minus 0.25, because you are taking here 0.26, 0.25, because the summation is equal to this one. The summation is equal to this one. That's why. So I am taking here 0.25. If you take minus 0.26, then there you will get some error. That a fractional error. 6668, 0.78. So that summation will come 0.78 minus 0.78. That's why this is equal to the unbalanced moment. The distributed moment is equal to the undistributed or unbalanced moment. So this is the process is over. Then again you have to go for the carryover. So half of this moment will carry over to this side, and half of this moment will carry over to this side, and half of this moment will carry over to this side. And here there is your no carryover takes place. And also for a vertical member, so half of this moment will carry over to the bottom end, and here there is your no carryover takes place because as the end F is your simply supported. So this is the carryover. Again, you have to go for the distribution. So here 0.05 into 0. So here 0. And what is the moment, net moment here at joint B? This side there is no moment, and this side minus 0.13. So the net moment is minus 0.13. So this moment will be distributed to BA, BC, and B. This into 1 by 3, and you have to put in opposite sign. This into 1 by 3, and you have to put in opposite sign. And coming to the joint C, so here 0.05, and this moment also you have to distribute to CB, CD, and CF. This into 1 by 3 minus 0.02, this into 1 by 3 minus 0.02, and also to the vertical member into 1 by 3 minus 0.01, because I am taking here minus 0.01, because summation is your minus 0.05, the balance, and unbalanced is your plus 0.05. Here also minus 0.13, this is 0.4, this is 0.04, and here I am taking this is 0.05 actually. You should take 0.05. Then it will come minus 0.13. So this is the distribution of the moment. Then after distribution of this, so here you got the fractional part 0.0 something. If you go for the next cycle, then you will get that very small fraction. That's why there is no need to go the next cycle, and you have to add up all the moments here. So that is moment for distribution. So from that and below, you have to add all the moments. So minus 40 plus 1.67 plus 0.77 plus 0.05. So after addition of this one, so you got here minus 37.51. Then you go to this one, this column 40 plus 3.33 plus 1.53 plus 0.09 plus 0.04, 44.99. And here also, because the summation should come 0. But here you see at joint B, here how many member meets? BA, BC, and B. So here this is your 44.99, this is your 50.01, and this is the addition of the top member 5.01. So here you see at the joint B, 3 member meets. BA, BC, and B. The summation of these 3 moments should equal to 0, because you know at a joint, at any joint, the sum of the moment is equal to 0. Here you, this is your 44.99, and this side is your minus 50.01, and you got this is your 5.01. So the summation should be 0. 44.9 plus, this is plus, and here this is your minus. So this is your equal to 0. Clearly at joint, the summation of the moment is equal to 0. CB, CD, and CF. So here after addition of this moment, so here you got minus 9.98, and this is your plus 42.48, and this is minus 32.51. So this should be equal to 0. 42.48 minus 32.51 and minus 9.98 is equal to 0. And here this is you got 0, and this end also you know 0. So these are the final moments of the frame. So then what is the next step? So this is the final moment. MAB your minus 37.51 kilonewton meter, MBA 44.99, MBC minus 50.01, MB 5.01, MCB 42.48, MCD minus 32 point, MCF minus 9.98, MTC 0, MFC 0, and MEB plus 2.49 kilometer meter. Then you have to draw the bending moment diagram. So for bending moment diagram, what you have to do? Here you see, these are the loading. So you have to find out what is the pre-BMD, what is the positive bending moment diagram due to the load present on the member. And here also there is you are having the point load. So due to this point load, what is the free bending moment diagram? You have to find out the maximum positive moment, and also due to UTL, you have to find out what is the maximum positive moment. Then after getting the maximum positive moment, then you can plot the free bending moment diagram. You know that a support moment. So already you got from the iterative process, and after getting this free BMD, then you can plot the bending moment diagram of this frame. So free bending moment diagram, free moment in span AB, BC, and CD. So you have to find out maximum positive moment at midpoint of AB. You know that is how to find out WL square by 8 if UDL is your present. So the moment is the maximum positive moment is your WL square by 8, 30 into 4 square by 8, 60 kilonewton meter. Then maximum positive moment at midpoint of BC. So this is your point out present at the midpoint. The moment is your equal to WL by 400 into 4 by 4, 100 kilonewton meter. Similarly, for span that CD span, the UDL is present. The maximum positive moment at midpoint is your WL square by 8, 20 into 3 square by 8, 22.5 kilonewton meter. So these are the maximum positive moment for free bending moment diagram. Then you can plot you have to give the direction of the moment. Here you see, so for span AB, minus 37.51, negative. So you have to give the direction anti-clockwise. Then MBA plus 44.99. So here you have to give clockwise. Then MBC minus 50.01. And once again, negative means anti-clockwise. BC, anti-clockwise. Then MB plus 5.01 means clockwise. Clockwise means this is the clockwise. This is your B. So this is the direction of clockwise. Then MCB plus 42.48 plus 42.48. So here MCB plus clockwise. This is CB. This is CB. So this is clockwise moment. Then MCD minus 32.51 minus MCD. This is your CD. So this is your minus means anti-clockwise direction. Then MCF minus 9.98. Once again, this is anti-clockwise. CF, this is anti-clockwise. Anti-clockwise. Here you see this is anti-clockwise, this is anti-clockwise, this is clockwise. So this summation is equal to 0. Here also this is clockwise, and this is anti-clockwise. The summation should be 0. Then MDC 0. MDC 0 because this is simply separated. This is there is no moment 0. Then MFC 0. This is also 0. Then MAB plus 2.49. Plus means this is your clockwise. EB this is clockwise. 2.49 this one. First you give the direction of the moment as for getting in the iterative process analysis. Then what you have to do? Then you have to draw the bending moment diagram. Here you see, so this is the moment. So here you give this 37.5 if the moment direction is your upward, and if this is your downward, arrow mark is downside. So you have to take downward, and this is your upward side. So here you take 37.51 the moment here. Then MBA is equal to 44.99. So this is 44.99. Then MBC minus 50.01. So here you see this is your 50.01. BC 50.01. Then MB 5.01. Here you see this is your 5.01. This side 5.01. This side 5.01. Then CB, MCB is your 42.48. MCB is your 42.48. So here you draw. Here. Then MCD is your minus 32.51. And this is this one. So this side 32.51. Then MDC is your 0. So you draw this line, and here also for BC, draw this line, and then for CD, draw this one. AB, BC, and then then this side is your, and this is this side. So this side means this side is your 2.49, and this side means this is your 5.01. And here also for vertical member, this side arrow mark anti-clockwise. So this is 9.98, and here this is your 0. Here this is. So this is the support moment diagram. Then you know the free BMT from the loading, what is present on the member. So you know that is for AB. So what is the free AB? So the maximum positive moment is your 60 kilonewton meter at the midpoint. And due to UDL, the free BMT is your parabolic, and this is the maximum positive moment. So this is your positive diagram, and this is negative diagram. So here this portion is your cancel. So this is remaining negative, this is positive, and this is negative. Similarly here, so due to this concentrated load at the midpoint, so what is the maximum positive moment? WL/4 100 kilonewton meter. So here this is your 100 kilonewton meter, and this will be triangle, and this is your negative. So this portion is your cancel. This portion positive negative cancel, and here remaining negative, and this is also negative, and this is positive. Similarly, here that you are having UDL. So what is the maximum moment? 22.5 WL²/8 positive moment, and this is also parabolic. Draw parabolic, and here this is negative. So this portion is your cancel, negative positive. So here remaining this is positive, and this is negative. And here there is no external load, so there is your no free BMT. Only this is your sufficient, this due to the support moment. And here you see one thing, you have to find out what is the maximum positive moment here, cancelling this positive and negative here. So you have to find out what is the maximum positive moment. You know that is how to find out this one in other methods, slope deflection or fixed and fixed beam also. So you have to find out, so what is the maximum positive moment. Similarly, here also you have to find out what is the maximum positive moment here also. Similarly, here also you have to find out what is the maximum positive moment here. Now you are clear, that is, so how to solve the frame, that non-sway frame by moment distribution method. So all are clear.